First things first, we're going to work on identifying the type of transformation. So looking here at number 1, it says to complete the following. Triangle 1 was reflected to create triangle 2. So here's our triangle 1 and it reflected to create triangle 2. In our instructions here it says triangle PNW, which is this one, PNW, was reflected off of the blank. Here what they're asking us to identify is whether it was the x-axis or the y-axis. So the way you can do that is first test out the x-axis is the one that runs from left to right. So what you're imagining is if I were to fold this paper in half, right where this pink line is, would triangle 1 land on triangle 2? I know it's kind of hard because this is a packet, but if I were to fold it in half, would triangle 1 land on triangle 2? The answer is yes. So I would claim that it is a reflection off of the x-axis. But let me further prove it to you by using a piece of patty paper. So what you want to do first is you want to go ahead and line up your patty paper onto the image, and you want to copy number 1, which is this one here. So you're going to have P, this is N, and this is W. And it's so important that you label the points so that way when you're asked to identify congruent parts such as angles and line segments, it will be simple. So now, because I'm claiming it is reflected off of the x-axis, I'm going to go ahead and draw a reference line. First using my origin. I can choose either direction. I can choose either the line pointing to the west or the line pointing to the east. It doesn't matter. I just would suggest that you only pick one direction. So let's just go ahead and pick pick east in this case. So to verify that this is a reflection off of the x-axis, what I'm going to want to do is flip this paper over, but make sure I'm still having this arrow point to the east. Now, notice there's going to be 2 ways to flip your paper. You can flip it like a page in a book, which would be this direction here. Let me show you one more time. You can flip it like a page in a book, which would be this way. But notice when I do that, my direction is now pointing to the west, which is not what I want. So I'm going to retry that. I'm going to try to make sure it's still pointing to the east. So instead of doing that, I can flip it over like a calendar. So I'm going to flip it this way. And you're going to notice what's nice about it is it's still pointing to the east and it nicely lined up with triangle 2. But if that was too fast, I'm going to try and show you one more time. This is where I started. I can go ahead and flip it like I would for a calendar. So I'm going to flip it over. And notice I'm going to line it back up and it's still pointing east. So that's a good sign. So in this case, this verifies that it was a reflection off of the x-axis. But now that I've done that, I am asked to finish a congruent statement. See here, it says triangle PNW is congruent to. Well, first of all, it's congruent to another triangle. It's congruent to triangle 2, but let's give it a more specific name. Let's see what's underneath P. If you take a peek, under P is the letter D, so I'm going to say it's congruent to D. N is right here. I know it looks a little strange because it's been flipped over, but if I look under N, it's going to be the letter C. So I'm going to say D, C, and last but not least, W. I know this looks like an N, but remember it's because we flipped it over. We're going to look under W. Now it looks a little bit better. W was underneath the letter H. So I'm going to go ahead and say that triangle PNW is congruent to triangle DCH. But now I have some more congruent statements to fill out. I would say angle P is congruent to angle. Let's take a look under P, the letter D. So angle P is congruent to angle D. Angle N is congruent to angle C. Angle W is congruent to angle H. Line segment PN, well let's see, line segment PN would be congruent to line segment DC. Don't forget to put your line segment on top, that little bar. Line segment NW, which is right here, would be congruent to line segment C and H. Last but not least, line segment PW is congruent to line segment DH. So we went ahead and successfully identified what line the shape was reflected across. In this case, it was the x-axis, which allowed me to identify all the congruent angles as well as line segments. But now let's go ahead and try one more example where we're asked to identify what type of reflection it was, whether it's off of the x-axis or the y-axis. So in this case, I would ask myself first, triangle 1 was reflected to create triangle 2. How did that happen? Was it being reflected off of the x-axis? So in other words, would I fold the paper along this line so that 1 would land onto 2? Or should I fold it along this line so 1 would land onto 2? Hopefully your answer would be this line right here, which we refer to as the y-axis. So again, if I took this piece of paper and I literally folded it in half, triangle 1 would land on triangle 2. But I'm going to further prove it to you by using a piece of patty paper. So first things first, you're going to have to copy triangle 1, which is this one in this case. And it's always important that you keep all parts labeled. So here's your F, here's your H, and this one is your B. Now, since we are guessing that it is a x-axis reflection, and we're going to draw a reference line, we have an option to either have it point north or south. Let's go ahead and use south in this case. Remember, there's two ways to flip it over. I can flip it like this, but what you're going to notice is my south is now pointing north, which is not a good thing. So let's retry that one more time. We want to keep the direction facing the same. So in this case, since it's facing south, I'm going to flip it the opposite direction, which would be like flipping a page in a book. And you're going to find that it can still point to the south. So that would be our correct reflection, which is truly along the y-axis. So I'm going to go ahead and write that in as an answer. That triangle FHB is reflected off of the y-axis. Now that I've done that, I'm going to go ahead and write my congruent statement. It says, finish each congruent statement. Triangle FHB is congruent to another triangle. Well, let's see. F corresponds to, and if you're wondering what corresponds to, it means it's matching set. So F corresponds to the letter Q. H corresponds to the letter W. And then B corresponds to the letter N. So I would say triangle FHB is congruent to triangle QWN. But now we're going to go ahead and list all the congruent angles as well. So here for the first one, it says angle H is congruent to angle, well, let's see, angle H is congruent to angle W. Angle F is congruent to angle Q. Angle B is congruent to angle N. Now we're going to do the same thing, but we're going to do it with line segments. So the first one is line segment FH. FH is congruent to line segment QW. Line segment FB is congruent to line segment QN. And line segment BH is congruent to line segment NW. So there you have it, yet another reflection. So in this case, we were identifying where the line of reflection was, and we went ahead and identified all congruent parts. So in the previous examples, we were identifying the different types of reflections, and now we're going to go ahead and practice performing different types of reflections. So for number 7 here, it says reflect triangle RSL on the same graph. In this case, for number 7, they want us to reflect triangle RSL across the x-axis. To make things easy, I am going to first highlight my x-axis so I know what I'm referring to. And I'm going to go ahead and start with the letter R, which they conveniently gave me the ordered pair for. So here, starting at the line of reflection, which is the x-axis, I'm going to start to see where R is. So here, I'm going to see that R would require me to go 1, 2, 3, 4, 5 down, which is south. I'm going to go back to -6, but instead of going down 5, I'm going to go the opposite direction, would be up 5. So we're going to go 1, 2, 3, 4, 5. So we're going to label this point R, but because it's after the transformation, I do have to put a prime symbol. So I went ahead and gave it a new ordered pair, which becomes -6, 5, which kind of looks similar to the original ordered pair. Something to keep in mind. Now I'm going to move on to S. S here, starting at the line of reflection, it lines up nicely with 2. I'm going to go ahead and count and see that's going 1, 2, 3, 4, 5, 6, 7, 8 down. I'm going to go the opposite direction. Instead of going 8 down, I'm going to go 8 up. But I do need to start back at 2, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8. We're going to go ahead and put a point here. We're going to make an S, but to tell us that it's after the transformation, I'm going to put a prime symbol like so. And the new ordered pair would be 2, 8. So to compare that to the original, I'm noticing something that they have in common. Okay, trying to see if there's a pattern. Last but not least, we have L here. Okay, for L is different. L lines up with -6, but for L, I'm going to have to move up 1, 2, 3, 4, up. So now instead of going up, I have to go the opposite direction, which is down. We're going to go 1, 2, 3, 4. We're going to label that L prime to indicate it's after their transformation. So you're going to see here that it's going to create this image here, which is a reflection off of the x-axis. So something that's different about this one is you're going to see that these images overlap just like the previous example. So L prime did become -6, -4. So some of you may start recognizing a pattern, which is amazing. If you don't see it quite yet, that's okay. Hopefully with some more practice, you'll start developing that pattern on your own. Now let's go ahead and practice one more time, but let's do the next one, which requires us to reflect the original triangle across the y-axis. So I'm going to go ahead and use a different color so we can see the difference here. We're going to go ahead and start with the letter R, but notice we are reflecting off of the y-axis, so let's go ahead and highlight that real quick. So for R is right here. That lines up with -5 along the y-axis. Notice I'm going to have to move 1, 2, 3, 4, 5, 6 to the left. So starting back at -5, I'm going to go 6, but this time I'm going to go to the right. 1, 2, 3, 4, 5, 6. So that's going to be my R prime. So there it's going to become 6, -5. So this pattern looks slightly different. You're going to notice we used R prime one more time because we did use the original one, not the new one. Okay, so let's continue on with S. For S, from the line of reflection, it lines up with -8. I'm having to move 2 to the right. So the opposite would be move 2 to the left. So we're going to label that S prime. So the new ordered pair is going to become -2, 8. And again, hopefully you're starting to recognize a pattern. Okay, I'm so sorry, it should be -2, -8. That is a negative number. The pattern is going to make a lot more sense now that I've corrected it. And last but not least, for L, we have, where's L? It's right here. Lining it up with the y-axis, it's moving 1, 2, 3, 4, 5, 6 to the left. So I must move in the opposite direction and go 6 to the right. 1, 2, 3, 4, 5, 6. So we're going to label that L prime. So now all I have to do is go ahead and connect the points, and that would be my reflection across the y-axis. But almost forgot, the ordered pair for L prime would be 6, 4. So hopefully you're able to recognize the pattern. If not, that's okay, as long as you are able to do the reflections is all that matters right now. We will dig in deeper at a later time this year.